Hey, algebra students, Mr. Lawrence here, making a review video on absolute value inequalities. Now, many of you will do this wrong. Many of you will see this and you'll start going like -1 like that. Do not do that. It is absolutely incorrect. You have never seen me do that. It is not okay. Remember, the definition of absolute value is the distance from zero on a number line. I call this an and problem because that's a less than symbol, right? Remember, less than. This is an and problem. I know that the graph is most likely going to look something like this when I'm done, okay? To do an and problem, I need to write two inequalities. I need to write 3x plus 1 is less than or equal to 8, and 3x plus 1 is greater than or equal to -8. Now I can go ahead and do my algebra. I'll subtract 1 from each side. I'll get 3x is less than 9, less than or equal to 9. Oh, no. That'd be a 7 there. Right? That'd be a 7. Sorry about that. Okay. And then I'm going to divide by 3. By 3, x is going to be less than or equal to 2 1/3. Okay. And, remember me doing that a long time ago? And now I'm going to solve this inequality. Notice I'm not just going to go x is greater than or equal to -2 1/3. I'm actually going to solve the inequality. So important that you write down both inequalities. 3x is greater than or equal to -9. Divide by 3, divide by 3. X is going to be greater than or equal to -3. So both parts have to be true at the same time. So on my number line, I'm going to show the -3, and I'm going to show the 2 1/3. All right. Now, they're going to be closed points because I said the word equals, right? Less than or equal to. If I didn't say equals, they would be open. And since it's an and, I need all the numbers that are less than 2 1/3 and greater than -3 at the same time. Well, they would all fall inside here. So here's the solution. Here's the graph. All right. Now, one like this is called an or problem. This is an or because it's a great or, like a greater, great or. And I know its graph is going to look something like this. Right? Remember that? Okay. I have to write two inequalities. 4x minus 2 greater than 6, or 4x minus 2 is less than -6. Notice I flip the inequality and make it negative. All right, again, I'm going to solve both parts. So I'm going to get 4x is greater than 8. I added 2 to both sides. X is going to be greater than 2. Is it time to eat? And then I'm going to get 4x is less than -4. So x is going to be less than -1. There's my solution. Now I'm ready to graph. So I need a -1. I need a 2. I'm going to have open points because notice the word equals never was said. Absolute value of 4x minus 2 is greater than 6. X is greater than 2 or x is less than -1. Never said equals. All right, so where are the numbers greater than 2? They are to the right of 2. Where are the numbers less than -1? They're to the left of -1 on the number line. And there you go. All right, if I had an equals, an equation, absolute value of 5x plus 10 equals 20. I'm going to do it like an or problem. I'm going to go 5x plus 10 equals 20, or 5x plus 10 equals -20. And I'll solve both parts. I'll get 5x equals 10, x equals 2, and then 5x equals -30, x will equal -6. All right, now if I wanted to do that one on the number line, that's not as common, but I certainly can do it. I'm going to have to show a -6, have to show a +2, and there'll be closed points. There won't be any shading because there's no inequality. There's only two possible answers. X is -6 or 2. Okay, x can't be anything in between there. Man, that bracket looks pretty bad there. Sorry about that. My penmanship skills go down when you're using the airliner. Oh, that's not much better. But anyway, you know, I can't make them. There we go. I'm trying to make those guys. There we go. I'm feeling better about myself. I did it right. I don't like those. There we go. All right, so that's it for the video. Mr. Laurence signing off. Have a good night, everybody.